Hello, we're doing Chapter 5, Section 6, where we're learning about the world-famous quadratic formula. So in this video, we're going to be doing 3 examples of how we find the zeros of quadratic functions by using the quadratic formula. And actually, that's really all we're going to be doing. In one of the examples, we're going to talk about something called the discriminant, but I'm going to kind of break the sequence a little bit, and I'm going to start talking about the discriminant now. All right, so what is the quadratic formula? Well, we just did that in the previous video. We should have that handy. The quadratic formula is x equals, and it's a big fraction, so I get negative b, or the opposite of b, plus or minus. The plus or minus comes in front of the radical, and then I get b to the second power, subtract 4 times a times c, and in the denominator I get 2a. That is the quadratic formula. Now, where did the a, the b, and the c come from? Well, if you remember from the previous video, it comes from standard form. And actually, I should have written that first. Standard form is ax squared plus bx plus c equals 0. So I need to first recognize my quadratic function or quadratic equation as being in standard form. If it's not, I need to put it in standard form. And then I just figure out what my a, my b, and my c are. All right, there's a couple things that I want to mention before we actually start to work with this. In my experience with both the teachers that I had and also teachers that I've talked to, a lot of times, and actually a lot of times it's students who have already done this in Algebra 1, because we do this in Algebra 1. A lot of times teachers will just have you start to put the a, or here and here, the b and the c into the formula, and then you just keep simplifying, and get it down. I always find that to be a little awkward and unwieldy. So I'm going to show you, and there's not a trick to this, okay? It just means you're going to end up doing this anyway, so just kind of do it separately, kind of like, when, like when you're making a recipe, like if you're making a pie, you kind of like mix up this part and you set it aside for a moment, and then you work on the other part, and then at the end you put it all together. That's essentially what I'm doing. All right. This part right here I want to talk about, because this is the important part. Well, actually, the whole thing's important, but that square root is what makes this into a way of solving quadratics. Because remember, completing the square and other stuff, we use square roots. The positive and the negative, that means I get 2 solutions. Negative b plus this divided by this, and negative b minus this divided by this, okay? But I want to talk about this part. I'm going to cover up that. I want to talk about this. That's the radical part. And the cool thing is that radical, if b squared minus 4ac is a perfect square, like 1, 4, 9, 16, 25, 36, 49, etc., then when I take the square root of it, I get a nice number. And then everything works out nice. And if I use the quadratic formula on, like say a quadratic equation, or find the zeros of a quadratic function that you could easily do by factoring, that's going to happen. But it's not always going to happen. And the quadratic formula is powerful because it always works. Sometimes what's underneath here is going to be like a number. It's not going to be a perfect square. So it could be like 13, and I end up with the square root of 13 in my answer, which is fine. Sometimes I'll get a nice number like 0. So b squared minus 4ac could equal 0. When that happens, I get the square root of 0, which is 0. And then when I do plus or minus 0, that doesn't change anything. So that's kind of cool, all right? But that's a special case. That's when I have a perfect square to begin with. Sometimes b to the second power subtract 4ac, if this part 4ac ends up being bigger than b to the second power, I get small subtract big, which means I get a negative. And when I take the square root of a negative, I'm going to end up with the unfortunately named imaginary solution, and I'll get a complex answer. So there's all kinds of things that are going to happen. What happens is determined by this. B squared subtract 4AC is called the discriminant. All right? And discriminant, I guess we use the word discriminate in a very negative way when we talk about people, but I just want to be clear that you understand we're not talking about people in this situation. To really truly discriminate means to separate. All right? So to say, all right, I'm going to sort. Another way is to sort it. And of course, again, just I can't avoid it. We don't want to separate or sort people in ways that are unfair. Okay? I suppose you could do it. We do it all the time because we have you sorted into different classes and we have you sorted into like different grade levels. But we don't want to sort people in ways that are unfair. So, and also, since I'm probably going to be posting this on YouTube, I just don't want somebody coming back and saying, you were talking about discrimination. I recognize it, but that's not what we're talking about, right? When we talk about this being sorted or discriminated, we're going to sort it into, do I get 2 answers? Do I get 1 answer? I should say solution instead of answer. Or do I get 2 imaginary solutions? And remember, I said 1 solution. I should have caught myself. That's when I get the same thing twice. All right, so I always get 2. So what I like to do is to first deal with this. So let's show you what I mean by doing this problem, all right? I've got f of x equals, I'm going to write it, f of x equals x to the second power plus 10x plus 2. That's my function. I want to find the 0, so I have to set this equal 0. This is important that you do this and make sure that you show me that when you're doing these problems. So I have to have 0 equals x to the second power plus 10x plus 2. This is in standard form. I don't have to mess with it or anything. I'm using a function, so it's in standard form. Later when we use equations, I'm going to have to mess with it a little bit. I get a equals 1, because it's 1 times x squared. I get b equals 10, and I get c equals 2. So what I like to do, and I know Corbett also does the same thing, is I like to first find out what the discriminant is. The discriminant is going to be b to the second power, subtract 4 times a times c. Okay, what's my b? My b is 10, so I got 10 to the second power. What's my a? 1. What's my c? 2. Excuse me. All right, let's simplify this. 10 to the second power is 100. 4 times 1 times 2 is 8. And 100 minus 8 equals 92. All right, cool. That is a positive number. So when I take the square root of it, when I put it in the next step under the radical, I'm going to get 2 distinct solutions. Now you're thinking, okay, that's all well and good, but I haven't figured out what x is yet. Well, then this is where this kicks in. X equals negative b plus or minus the square root of b squared minus 4ac. Sorry, I didn't mean to make that wiggly. Divided by 2a. All right, let's start replacing all this with what I know. B is 10, so I get negative 10 plus or minus the square root. All of this is just 92, so I'm just going to write 92. And of course, 2 times a is 1. So now I've got just a couple things to do. Right. All right, so I want to find the opposite of 10, which is negative 10. I can leave that. I want to simplify. 92 is not a perfect square, so I want to simplify. It's even. Sorry, excuse me. I was trying to say 2 things at once. It's even, so none of the odd perfect squares is, well, that's not true. Okay, I should probably check it. 92, let's see. If I do 92 divided by 4, okay. And by the way, that's prime, so that's going to make sense. So this is actually, I'm going to write up here, the square root of 92 is actually the square root of 4 times the square root of 23. Okay, so I'm going to simplify it a little bit. Don't forget the plus or minus. 2 times the square root of 23, and then 2 times 1 equals 2. And the last thing I need to do, I'll write it out, but usually I don't write it out as a step. This is the same as negative 10 divided by 2 plus or minus 2 times the square root of 23 divided by 2. So basically I'm going to take the negative 10 divided by 2 and the 2 divided by 2, and everything's going to simplify. So I get x equals negative 5 plus square root of 23. That's one of my answers. Move that so you can see it. And negative 5 subtract the square root of 23. Okay, now that's a lot for one problem, so let me do another problem with you, and then you're going to see what I'm going to do here. All right? So first, set it equals 0. I get 0 equals x to the second power plus 3x subtract 7. Let's identify what a, b, and c are. My a is 1, my b is 3, and my c is negative 7. Let's take care of the discriminant first. B to the second power subtract 4 times a times c. B is 3, so I get 3 to the second power. A is 1, so 4 times 1, and c is negative 7 times negative 7. I'm going to square this, I'm going to multiply all this, then I'm going to subtract. So I get 9. Negative 4 times 1 times negative 7 is positive 28. And 9 plus 28 is 37. So I got a positive number. That means I'm going to get 2 distinct solutions, which means I always get 2 solutions, but they're going to be different from each other. And they're also going to be real, right? So now let's go into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. B is 3, so I get negative 3. Plus or minus b to the second power minus 4 times, I left off the c, you should have told me. B to the second power minus 4 times a times c is 37. So I get square root of 37 here. All over 2 times 1, which is 2. Alright, now, unlike last time, I don't know what the square root of 37 is, because 37 is prime. Alright, and by the way, even if it wasn't prime, sometimes I can't simplify it. I just know that since it's prime, and since it's not, I'm not going to have any factors that are going to be perfect squares. So I should be more clear about that. That's why I'm making the videos. It's always nice to have people ask me questions. So what I get negative 3 plus or minus whatever the square root of 37 is. And the only thing I have to really do is 2 times 1 equals 2. Now you can leave it like that, or I'm okay if you write it this way. Negative 3 divided by 2 plus or minus the square root of 37 divided by 2. But again, this is okay, that's okay also. You can even write it separately. Negative 3 over 2 plus square root of 37 over 2. And negative 3 over 2 subtract square root of 37 over 2. Because I want to keep reminding you that the plus or minus means I get 2 different solutions. Let's do this one. So first, set it equals 0. Identify what your parameters are. So my a is 1. Well, it's been nice that a's been 1, hasn't it? My b is negative 8, and my c is positive 10. My discriminant, b to the second power subtract 4 times a times c. That's negative 8 to the second power. My a is 1, so negative 4 times 1, and my c is 10. Negative 8 to the second power, negative 8 times negative 8 is positive 64. 4 times 1 times 10 is 40, so I'm going to subtract 40. And I end up with 24. And like the other 2 problems, this is a positive number, which means I get 2 real distinct solutions, two real solutions that are different from each other. All right. My quadratic formula one more time, negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. b is negative 8, so I get the opposite of negative 8. The discriminant, b to the second minus 4ac, is 24, so I take the square root of 24. And I get 2 times a, which is 2 times 1. All right, let's take care of that, take care of that, and take care of that, and then we'll see if we can do anything else with it. The opposite of negative 8 is positive 8. You can put the plus sign in front of it if you want. I don't care. 24 can be factored. 24 is 4 times 6. The square root of 4 is 2, so I get positive 2 times the square root of 6. And then, of course, 2 times 1 equals 2. All right, now last time I separated this, let me show you. Last time I separated this into two different fractions and then I simplified. If you want, you can recognize right away that I'm going to have 8 divided by 2, which is 4. And I'm going to have 2 divided by 2, which is 1, so I get 4 plus or minus the square root of 6. So please make sure that you remember to simplify. All right. We'll see you in the next video.